derivative test. The first step to the first derivative test is to actually complete finding your increasing and decreasing parts of your function, including your critical values. You need to know your intervals and things of that nature. So I went ahead and I found the derivative and I set it equal to 0, and I found my critical values. Also, if you're unsure of how to do this and why this works, I would go and watch the last video that is increasing and decreasing functions. Okay. So then I'm going to complete my increasing decreasing functions chart right here that I made earlier. So my interval right here is going to be from negative infinity to -2. So really, in all reality, you can actually write these one of two ways. You can write it like this, or you could write it like negative infinity to with open brackets. And for the sake of this video and for understanding, I'm going to write it like this. I also like this just because it's shorter, but I do see most people writing it in this form, or not most people, but many people do, because it's helps you understand that it's an interval more. But for the first derivative test, this definitely makes more sense. Negative infinity to -2. -2 to 1. And 1 to infinity. Okay. That's a messy infinity symbol. Okay. So I'm going to use our test value as being, let's say, -3. How about here? Let's use 0. And here, set x equals 2. Okay. So the sign of the derivative, let's plug in f for f prime of x. For x, we're plugging in our 3. And I did the math earlier. So this is equal to 24. Plugging it back into our derivative equation right here. F prime of 0 is going to be equal to -12. And f prime of 2 is going to be equal to 24. Yes. Okay. This is positive, meaning these are both increasing. This one's negative, so it's decreasing. Like I said before, increasing. Okay, so to do our value test, what we have to do is actually take our critical numbers and plug them into our original equation. So, for the most part, I don't need this anymore, but I do need some of it. I need to know my intervals, and I need to know my conclusion. So, I'm going to erase part of this for right now. So I have more room to work. But we know that right here, this was increase, this was a decrease, and this was an increase. Okay. Okay. So right here, we're going to take f of x, and we're actually going to make it x is negative 2. So then we do 2 times negative 2 quantity cubed plus 3 times negative 2 squared minus 12 times negative 2. And we are going to find out that this is going to be equal to 20. I believe. Let me double check that really quickly, because I could be doing my math wrong. No, that's correct. Okay. And then if we do f of 1 is equal to 2 times 1 cubed plus 3 times 1 squared minus 12 is 1. Right? We're going to find out that this is equal to negative 7. So what do we get from this? Let me make sure you can see this. There you go. What do we get from this? Well, what we are getting is this is our y coordinate, these numbers right here. Then we already have our x coordinate. So this x, so let me write these out for you now. So this is going to be is negative 2 20, and this one is going to be 1 is our x, and then negative 7 is our y. So these are points on our graph at which we have a relative maximum or relative minimum. And because we can see that this function goes on to infinity from our intervals, these are like the maximum ones and the minimum ones in a certain localized area. Because when you're looking at this, I mean, yes, it does go on to infinity, but sometimes you do want to know overall in a reasonable area where you can actually find your minimum or maximum, what is that? So these are those points. And now you need to know which one's your maximum, which one's your minimum, right? And you find that by looking back at your intervals. So this right here, negative 2 and 20, well, our negative 2 and 20 is going to fit into the interval. Let's see, which interval does it fit into? Fits into right here. So this is going to be our maximum, and this one is our minimum, because it's going to fit more into here. Also, you can know this not even looking at your intervals. This is actually probably just a better way of doing it. You can see that the y coordinate, this one's smaller, this one's bigger. This is going to be our minimum. This is going to be our maximum. So max, minimum. So just see which one has the larger y value. And that's all there is to your first derivative test. Really, you're just looking at, here, let me even just graph this out really quickly. We have 2x to the third plus 3x squared minus 12, right? And if I zoom out, because right now zoomed, oops, sorry. We can see right here, this is our graph, right? And if I find our minimum values now in this area, our localized area, we're going to see, like, it's going to show us kind of what we're expecting. And yep, so that's all there is to it. Sorry, that graph actually didn't show me right, but I clicked in the wrong area. Anyways, yeah, you can see that little dot is off from the minimum, but anyway, sorry about that. But that's all it's looking for, is it's drawing a tangent line, and then you're seeing the minimum there of your graph. And you can do that using the first derivative test, and that's what the first derivative test is for. I hope that was helpful. If you have any questions, let me know. Thank you for watching.